Okay, so that was an introduction to get you thinking about what this system actually looks like. Um, I want to also remind you of like, how did we get here? We just finished flocculation. And if you think about SWOT, which is strengths, weaknesses, opportunities, and threats for flocculation, and think about what we're trying to do with SWOT, safe water on tap. Here's what was great about flocculation. It rapidly reduces the number of primary particles, the raw particles that were present in the surface water. It reduces the concentration of them by converting them into flocks, okay? So it produces flocks that can be captured by either sedimentation or filtration further downstream. The weakness of flocculation is that it always leaves a significant number of those primary particles that haven't flocculated. And getting the last ones out is a real problem because remember the issue? Those small particles can only collide with other small particles, and there aren't many small particles left. And so it takes a long time to get a collision between those remaining small particles. And so it takes a really long time to significantly reduce their concentration. Their concentration, if you start out with 1,000 NTU water, really, really turbid chocolate milk, the concentration of unflocculated particles reduces super fast initially, but then it slowly goes to a crawl as the concentration keeps on dropping. So that's the weakness of flocculation, and hence we're going to try to solve that in the next step. And this was a reminder of why. So the small particles can't collide with the big flocks because there's this boundary layer around them that's spinning with the flock. And so the small particles just breeze right by and never come into contact with the flock. So that's our problem. And now for something completely different. This is what I did on Sunday. I created a new animation where I attempt to describe almost everything, not everything, but almost everything that's happening inside this FlockSed system. And in order to do that, I had to simplify it a little bit, but this is it's a simplification that just helps us think about what's going on. And so there are 4 categories of flocks that I want to introduce you to. So the blue one is a new flock that is brand new, and it is just joining the flock filter. And I'll explain where it comes from in a little bit. The blue and red dot flock is a flock that's in the flock filter that has become full of clay particles or other small particles. So it's taken on additional particles inside of itself and become full. The red particles are the primary particles. These are the bad guys, the clay, and for that matter, the cryptosporidium that we really do not want to drink. Or it also represents flocks that are too small to be captured by the plate settlers. So remember, each of these particles is really a type of particle, and there's a range of sizes in each one. And then the green one represents the flocks that settle fast enough to be captured by the plate settlers, but not fast enough to stay in the bottom of the sedimentation tank, in the bottom of the flock filter sed in the flock filter. So now let's go to the animation. So first of all, here are those 4 classes of particles again. And let's talk a little bit more about them. The smallest ones have a terminal velocity, their sedimentation velocity is less than the capture velocity of the plate settlers. And we'll talk more about what that means, like exactly how that works. But it means that they don't settle fast enough to be actually captured in the plate settlers. Wow, the next one gets more complicated. The green ones have a terminal velocity that is less than the upflow velocity in the sedimentation tank. So the water's going up in the sedimentation tank. These particles are trying to settle down, but they're settling down at a slower rate than the water's going up, so they're going up. But their terminal velocity is greater than the capture velocity required by the plate settlers, and so they are able to be captured in the plate settlers. So those are two of the small particle classes. The third and fourth particles both have terminal velocities where they're settling so fast that they can stay in the bottom of this flock filter sed unit. So they're going to end up hanging out in the bottom. So here we go. Here's the inlet. This is coming from, it's bringing water from the flocculator into the very bottom of the sedimentation tank, or this flock filter sed. There's plate settlers near the top, and there's an effluent manifold. It's got orifices in the top, and that's taking water and any particles that don't get removed out the top. So what's coming in? In the pipe from the flocculator, there are a whole bunch of green guys. Green guys are the beautiful flocks that the flocculator made, okay? So that's great. They're coming out, but they can't settle very fast. And they can't settle fast enough to stay in the bottom of this flock filter sed. And so what happens is, well, I'll get to there in a second. I forgot the order of my animation. Okay, in the bottom of the flock filter sed are a bunch of these blue and blue with polka dot guys. And you're wondering how they got there. I'll show that kind of as we go through this. So for now, take my word for it. They're sitting there, they're kind of hanging out, they're settling fast, the water is moving up through them, and so it's called a fluidized bed, and I'm realizing that in our normal everyday life, we don't really encounter many examples of fluidized beds of anything. I'm curious, did any of you ever see a rapid sand filter being backwashed? The water is going up through the sand so fast that the sand ends up being fluidized, it moves around. And if you were to jump into that sand filter, please don't, you would sink right into that fluidized bed because it's no longer settled, there's no structure there, it's all a fluid, even though there's sand, which is not a fluid, but it acts like a fluid. This is a fluidized bed of flocks in the bottom of the sedimentation tank. And if you poked your fingers into it, you would just experience it as being water with lots of flocks in it. Okay, so now we're going to look at what happens to these green guys. Those green guys go right up through the flock filter because they don't settle fast enough. And then, oh, what's happening now? There was an avalanche on the plate settlers, and they converted. Did you see that? This is one of the key conversions that happens inside the system. So let's do that again. So flocks from the flocculator go up onto the plate settlers, are captured on the plate settlers. They form an avalanche and they roll together and they form one of these brand new flocks that's going to now have a high enough terminal velocity that it can hang out in the flock filter. Pretty exciting. We just added a flock to the flock filter. Okay, what else is coming from the flocculator? Well, I just complained about the fact that in the flocculator, we fail at converting all of the red guys to green guys. So let's look at what the red guys do. So first of all, there's green guys everywhere in this system. So they're flowing. Matter of fact, their concentration is the same as in this system is the same as their concentration in the flocculator. So whatever's coming out of the flocculator is everywhere in the flock blanket as well, as an additional concentration of green guys. Now let's bring the red guys in. So the red guys also go up through. Oh, but it's so sad. Did you see what just happened? This was like what makes us cry. Okay, let's experience this again. Feel the pain. This red guy is going to pop in, and it goes up through the plate settlers, and it leaves in the effluent launder. And so what's our only hope for catching this guy? We've got a filter coming up, and we're hoping that the filter will catch it. And then there's one more thing we can do. If it is a pathogen, we can nail it with chlorine at the end. But we're kind of bummed because we were hoping to remove that guy in this flock filter set, but we lost it. But there was two red guys that came in. So let's watch this again, and now pay attention to the next one. So there was failure. Now another one comes in, and this one, whoa, did you see what happened to that? Did you see it? It landed right in the middle of a blue guy. Here we go again. First time failure. Second time, it came up and it went right into the middle of a blue guy. It went inside the flock and was caught there. So and I'll show more detail on what's going on with that. So we just converted a blue flock that was all blue, and we gathered its first red dot, and it's on its way to having lots of red dots. There's a problem with what I've drawn so far, and that is that I've got lots of particles coming into the system, and so far the only particles that have left was that one red particle that snuck out the top. And you all know that mass conservation is actually a thing. So there must be some other place where particles are leaving, and that's going to be, what did I forget? It's going to be a flock hopper that I'm showing here on the side of this flock sed filter. And every once in a while, a flock will pop across that weir. Well, every once in a while, a flock will pop across that weir and end up in the flock hopper. Oh, and did something just happen that makes you sad? Look at who went into the flock hopper. See, I'm beginning to cast this story in terms of good guys and bad guys. Like green guys are good guys, blue guys are good guys, red guys, we don't really like them because when we drink them, we feel really bad. And blue guys that are full of red guys, this is kind of sad, they're useless. They get full and they're useless. So what's sad is that the flock that ended up in the flock hopper was one of the good blue ones. And it would have been so much better if it had been one of the blue ones with red dots that had already done all it could for contributing to society and had taken all the red guys that it could along with it. I want to share this other crazy insight. You know, I've known about plate settlers for a very long time. And I don't think I've ever asked the question of how do flocks or particles that were caught in a plate settler, how do they get out the bottom of the plate settler and end up in the bottom of a sedimentation tank? So in a conventional system, there's not a flock filter. So there's not this concentration of blue and blue-red flocks in the bottom of a sed tank. The blue and blue-red flocks that I have here are because of our design that keeps them in suspension. But in a conventional sedimentation tank, those don't exist. They're all just in the sludge in the bottom of the sedimentation tank. So the question then is, how do the green guys that land on the plate settlers, how do they get to the bottom? And before creating this animation, I didn't realize how big of a question that was, and how the only way that they can get to the bottom is if they change their sedimentation velocity. Because the reason they got to the plate settlers initially in the first place is because they weren't settling fast enough to stay in the bottom of the tank. And so they went up to the plate settlers and were caught there. Now, the only way they can get back down to the bottom of the tank is if they increase their sedimentation velocity. And so that's what happens in plate settlers. It's a cool insight. Plate settlers act like little avalanche generators. And as the flocks are rolling down the plate settlers, they grow larger. And then they have a terminal velocity that's big enough that they can actually get to the bottom of the sed tank. That cool? Some cool, cool physics. Sedimentation just got more interesting, right? Okay, so now let's talk a little bit about what's going on in the flock filter. So the flock filter is a high concentration, it's a fluidized bed of flocks that is in a uniform upward flow. So the water is coming up, that's keeping all these flocks in suspension. In flock filters, small particles flow through the large flocks. So there's a large flock and small particles actually flow right through it. And as they're flowing through, there's a chance that they will collide and attach inside the flock. So that's this idea that flocks are filters. So when I call this a flock filter, it's in the same way that you could talk about a membrane filter. In a membrane filter, the membrane catches particles. In a flock filter, the flocks catch particles inside the flock.